Imagine this scenario. You're sitting in front of your computer at 2 a.m., scrolling through astronomical databases that most people have never heard of. The kind of rabbit holes that lead you deeper into cosmic mysteries than you ever intended to go. And then you see it. A single line of data that makes your pulse quicken. A measurement that shouldn't exist according to everything we understand about visitors from deep space. This is what happened to me when I first encountered the data for 3I Atlas. On July 1st, 2025, the Atlas telescope system in Chile, part of NASA's Planetary Defense Network, reported something extraordinary. Not extraordinary in the way that gets headlines, but extraordinary in the way that keeps astronomers awake at night, staring at numbers that refuse to make sense. They designated it 3I Atlas, also catalogued as C2025N1. That 3I designation tells you immediately that this is special. It's the third confirmed interstellar object ever detected in our solar system. The first was 1I Oumuamua in 2017, that cigar-shaped mystery that tumbled through our system before we could properly study it. The second was 2I Borisov in 2019, which at least behaved like a proper comet should. But 3I Atlas, this thing plays by its own rules. The discovery itself seemed routine enough. Atlas, the Asteroid Terrestrial Impact Last Alert System, is designed to spot potentially dangerous space rocks before they become a problem. It's a network of robotic telescopes scanning the night sky, looking for anything that moves against the stellar background. On that July morning, their automated systems flagged an object that was definitely moving, definitely not from around here. But here's what caught my attention in those pre-dawn database searches. When they traced back through their archives, they found images of this object dating back to June 14th, 2025. For more than 2 weeks, 3I Atlas had been quietly crossing our sky, captured in exposure, after exposure, waiting for someone to notice it was there. Think about that for a moment. An interstellar visitor, potentially carrying information about stellar systems dozens of light years away, silently documented in digital files while we went about our daily lives, completely unaware. The orbital calculations that followed painted a picture that should have been impossible. This wasn't some random chunk of ice and rock that had been wandering the galaxy for millions of years. The trajectory analysis revealed something that made veteran astronomers do double takes at their computer screens. 3I Atlas is following a nearly retrograde orbit, inclined at approximately 175 degrees. To put that in perspective, imagine all the planets in our solar system moving in roughly the same direction around a racetrack, and then imagine a car suddenly appearing, racing in the opposite direction at nearly the same angle. That's what we're looking at here. But the orbital mechanics are just the beginning of this story. What really makes this object stand out isn't where it came from or where it's going. It's what it's doing while it's here. The closest approach to our Sun, what astronomers call perihelion, was calculated for October 29, 2025. At its nearest point, 3I Atlas would come within approximately 136 to 1.4 astronomical units of our star. That places it just inside Mars' orbit, close enough to the Sun's heat to trigger the kind of dramatic changes we typically see in comets. And that's exactly what started happening. On October 3rd, 2025, 3I Atlas made its closest approach to Mars, just 0.19 astronomical units away. That's roughly 28 million kilometers, or about 1/5 the distance between Earth and our neighboring planet. Close enough that if Mars had been in a slightly different position in its orbit, we might have had a front-row seat to watch an interstellar object interact with another world in real time. Instead, we had to settle for Earth-based observations of something that was about to challenge everything we thought we knew about how comets behave. The December 19th closest approach to Earth was still months away, at a comfortable 1.8 astronomical units, or about 170 million kilometers. Safe, certainly, but close enough that our best ground-based telescopes could track every detail of what was happening as this interstellar visitor encountered the inner solar system for what might be the first and only time in cosmic history. What I discovered in those late-night data deep dives was that 3I Atlas wasn't just another interstellar comet. The measurements coming in from observatories around the world were painting a picture of an object that seemed almost designed to capture our attention. But designed by what? That's the question that keeps me staring at these numbers, wondering if we're witnessing something natural that we simply don't understand yet, or something else entirely. The data doesn't lie. But sometimes the data raises more questions than it answers, and with 3I Atlas, every new measurement seemed to deepen the mystery rather than solve it. Stay with me as we dive into what these observations actually revealed, because what astronomers found challenges our most fundamental assumptions about objects from interstellar space. Here's what makes your pulse quicken when you're looking at comet data at 2 a.m., a light curve that suddenly breaks all the rules. Every comet follows a predictable pattern as it approaches the Sun. As solar heating increases, more ice sublimates from the nucleus, creating a larger coma and brighter appearance. The relationship between distance and brightness follows well-established physics. We can predict how bright a comet should be at any given distance from the Sun, based on decades of observations. 3I Atlas was supposed to follow these same rules. The computer models, fed with the orbital parameters and early brightness measurements, generated clean predictions, showing a gradual brightening as the comet approached perihelion. And then, between September 7th and 15th, 2025, something happened that made those predictions worthless. The Comet Observation Database, COBS, tracks brightness measurements from professional and amateur astronomers worldwide. When you plot these observations on a graph, you expect to see a smooth curve, like a gentle hill, leading up to maximum brightness. What COBS showed for 3I Atlas looked more like a car that had suddenly floored the accelerator. The line on the graph, which had been climbing steadily through late August and early September, suddenly became much steeper. In the space of just over a week, 3I Atlas brightened far more rapidly than any of our models predicted it should. This is where rational explanations start feeling inadequate. The standard interpretation would be a sudden increase in outgassing. Perhaps the comet's rotation exposed a particularly volatile patch of surface ice to solar radiation, or maybe internal pressure from sublimating gases caused a small explosion that ejected more material into the coma. Comets are known to have outbursts, where they suddenly brighten and then fade back to their predicted levels. But there's something unsettling about the timing and duration of this brightness anomaly. Most cometary outbursts are brief, lasting days rather than weeks. They spike sharply and then decline. The 3I Atlas brightening event maintained its accelerated pace for over a week, suggesting something more systematic than a random volatile event. What if we're looking at something that was programmed to become more active at precisely this distance from the Sun? I know how that sounds. But consider this. If you were designing a probe to study our solar system, wouldn't you want it to become maximally active and observable when it was close enough to be studied in detail, but not so close that it would be damaged by solar radiation? The distance at which 3I Atlas began its anomalous brightening places it in what engineers might call a sweet spot, close enough to the Sun that Earth-based telescopes could capture detailed spectroscopic data, but far enough out that any artificial components wouldn't be fried by solar radiation. Of course, this could also simply mean that 3I Atlas has a composition unlike any comet we've studied before. Perhaps interstellar space conditions create ice formations that behave differently when heated. Maybe the millions of years spent in the cold and radiation of deep space fundamentally altered how this object responds to solar energy. But then I look at the precision of that brightness curve, the way it accelerated at exactly the right time to maximize our observational opportunities, and I can't shake the feeling that we're looking at something that was meant to be noticed. The brightness anomaly wasn't an isolated event. It was the opening act of a performance that would challenge our understanding of what comets can and cannot do. As September faded into October and 3I Atlas continued its approach toward perihelion, the brightness curve continued to defy predictions. Professional observatories trained their instruments on this interstellar visitor, expecting to solve the mystery with better data. Instead, what they found raised even more disturbing questions. The spectroscopic analysis revealed that the anomalous brightening wasn't just due to more material. being ejected from the nucleus. The actual composition of what was being ejected was unlike anything in our database of comet observations, which brings us to the next piece of evidence that suggests 3I Atlas isn't behaving like a natural object should. This is where the story gets really bizarre, and where the data starts pointing towards something that challenges our basic understanding of comet formation. On August 6, 2025, the James Webb Space Telescope turned its infrared eye toward 3I Atlas. JWST doesn't just take pretty pictures, it performs spectroscopic analysis that can identify the exact chemical composition of gases in a comet's coma by analyzing which wavelengths of light they absorb and emit. What came back from that observation session made researchers do double takes at their computer screens. Normal comets, the ones from our own solar system, have a fairly predictable composition. They're often called dirty snowballs because they're primarily water ice, mixed with dust and smaller amounts of other frozen gases like carbon dioxide, carbon monoxide, methane, and ammonia. When these comets approach the Sun, water vapor dominates the coma, typically making up 80–90% of the detected gases. 3I Atlas turned that expectation completely upside down. The JWST data revealed a chemical composition that reads like someone deliberately inverted normal comet chemistry. Instead of being primarily water vapor, the coma of 3I Atlas showed approximately 87% carbon dioxide, 9% carbon monoxide, and only 4% water vapor. Let me put that in perspective. It's like expecting to analyze the atmosphere of Earth and finding it's 87% nitrogen, 9% argon, and 4% oxygen. Technically possible, but so radically different from what we observe that it demands an extraordinary explanation. The immediate rational response is that 3I Atlas formed in conditions completely unlike those in our solar system. Perhaps it originated in a stellar system where water ice was rare, but carbon compounds were abundant. Different stars, different radiation environments, different available materials during planet and comet formation. This explanation works perfectly well for most of the chemistry. But then there's that green glow. Ground-based telescopes began detecting a distinct green fluorescence from 3I Atlas as it approached perihelion. This green light is produced when diatomic carbon molecules, two carbon atoms bonded together, absorb ultraviolet radiation from the Sun and re-emit that energy as visible light at approximately 518 nanometers. Every comet with significant carbon content produces this green glow to some degree. It's completely normal, completely expected, and completely explained by well-understood physics. What's not normal is the intensity and consistency of the green emission from 3I Atlas. The amount of diatomic carbon needed to produce the observed level of green fluorescence, combined with the spectroscopic measurements showing 87% carbon dioxide in the coma, suggests a carbon abundance that's nearly impossible to explain through natural formation processes. Carbon dioxide can photodissociate, break apart, when exposed to solar ultraviolet radiation, potentially creating the diatomic carbon responsible for the green glow. But the efficiency of this process, combined with the observed brightness of the green emission, implies a carbon dioxide abundance that seems almost engineered for maximum optical effect. What if the extraordinary carbon chemistry isn't a coincidence of formation conditions, but a deliberate choice? If you wanted to create an object that would be immediately recognizable as anomalous to any civilization with spectroscopic capabilities, wouldn't you design it with a chemistry that stands out from natural objects, a composition so unusual that it would demand detailed study? The carbon-heavy chemistry serves multiple purposes if we're looking at artificial design. Carbon compounds are stable across a wide range of temperatures, making them ideal for long-duration interstellar travel. They're also highly visible to spectroscopic analysis, ensuring that any technologically capable civilization would immediately recognize the object as chemically distinct. But of course, we could also be looking at the natural result of formation in a stellar environment completely unlike our own. Perhaps around a carbon-rich star or in the aftermath of a stellar catastrophe that created unusual abundances of carbon compounds in the stellar disk. The problem with that explanation is the precision of the chemistry. Natural processes tend to create gradients and variations. What JWST detected looks more like a carefully balanced mixture designed to achieve specific optical and spectroscopic signatures. As October approached and 3I Atlas neared its closest approach to the Sun, the chemical analysis became even more puzzling. Instead of the expected changes in composition as different ices sublimated at different rates, the chemistry remained remarkably stable, almost as if it were designed to maintain consistent properties across a range of solar distances. Which brings us to the next anomaly, one that challenges our understanding of how matter behaves when exposed to intense radiation. Here's what should have happened. As 3I Atlas approached the Sun, solar heating should have caused a steady, predictable expansion of its coma, the cloud of gas and dust surrounding the nucleus. We have equations for this. We have decades of observations confirming how comet atmospheres behave under solar heating. 3I Atlas apparently never read those textbooks. The coma expansion rate observed through September and October 2025 was, to put it in technical terms, absolutely absurd. Professional observers were reporting atmospheric expansion that was happening faster than our physics models predicted it should. When I say faster than physics predicts, I don't mean slightly faster, or within the margin of error. I mean the kind of faster that makes you check your calculations 3 times and then call a colleague to verify that your equipment is working properly. Some estimates put the total extent of the coma at approximately 700,000 kilometers by early October. To put that in perspective, that's nearly twice the distance from Earth to the Moon. The entire Earth-Moon system could fit inside the atmospheric envelope that 3I Atlas was dragging through space. But size alone isn't what made this anomalous. Large comae are unusual but not unprecedented. What was unprecedented was how quickly it got that large. The expansion rate suggests either that the nucleus of 3I Atlas is much more active than its size should allow, or that some other process is contributing to the atmospheric growth beyond simple solar heating and ice sublimation. The rational explanation focuses on composition. With its unusual carbon-heavy chemistry, 3I Atlas might sublimate differently than water-ice-dominated comets. Carbon dioxide sublimates at lower temperatures than water ice, potentially creating more atmospheric expansion for the same amount of solar heating. The carbon monoxide detected in the coma sublimates at even lower temperatures, meaning it could be contributing to atmospheric expansion, while the comet was still quite far from the Sun. Combined with the possibility that interstellar radiation exposure over millions of years created a more porous, easily sublimated surface structure, these factors could explain the rapid coma growth. But there's a problem with that explanation that keeps nagging at me when I look at the observational data. The expansion wasn't chaotic or variable, as you'd expect from natural outgassing responding to changing solar heating. The growth pattern was remarkably smooth and consistent, almost as if it were following a programmed sequence rather than responding to external conditions. Natural comets show variations in their outgassing rates as their rotation exposes different surface areas to sunlight, as they encounter pockets of different ice compositions, and as internal pressure builds and releases unpredictably. The coma expansion of 3I Atlas showed none of these natural irregularities. What if we're looking at controlled atmospheric deployment? If you were designing a probe for interstellar reconnaissance, you'd want it to deploy sensor arrays or atmospheric sampling equipment when it reached the target system. A rapidly expanding artificial atmosphere could serve multiple purposes. It could deploy nanotechnology sensors across a wide area, it could sample the solar wind and interplanetary dust environment, or it could simply create a larger cross-sectional area for more efficient data collection. The smooth, controlled expansion pattern observed in 3I Atlas is exactly what you'd expect from engineered atmospheric deployment rather than chaotic natural outgassing. Of course, this could also indicate that 3I Atlas formed under conditions that created an unusually homogeneous internal structure. Perhaps the low-temperature, low-pressure environment of interstellar space allowed for more uniform ice crystal formation, creating an object that sublimates more evenly than comets formed in our solar system's more chaotic early environment. But then, I look at the timing of the atmospheric expansion, how it accelerated precisely when ground-based telescopes were best positioned to observe it, and I can't shake the impression that we're watching a performance designed for an audience. The Coma expansion served another purpose that became apparent as October progressed. It made 3I Atlas much more visible to amateur astronomers and astrophotographers around the world. What had started as a faint smudge detectable only by professional observatories became bright enough and large enough for backyard telescopes to track and photograph. Almost as if something wanted to ensure that its visit would be widely documented and remembered. As the Coma continued its unprecedented expansion, professional observers began detecting something else that challenged our understanding of how comets behave. Polarization characteristics that had never been seen before in any natural object. This is where we enter territory that makes even veteran astronomers uncomfortable, because we're dealing with physics that doesn't just challenge our understanding of comets, it challenges our understanding of how light itself should behave when scattered by natural materials. Polarimetry might sound like an obscure technical measurement, but it's one of our most powerful tools for understanding what space objects are made of and how their surfaces are structured. When sunlight hits particles in a comet's coma, those particles scatter the light in predictable ways. The degree to which that scattered light becomes polarized tells us about the size, shape, and composition of the scattering particles. We've been doing polarimetric analysis of comets for decades. We know what the measurements should look like for different types of dust grains, different ice crystals, different organic compounds. The polarization signatures are like fingerprints. Each material type has characteristic patterns that we can recognize and interpret. 3I Atlas is producing polarization signatures that don't match anything in our databases. The measurements show a negative polarization value of approximately 2.7% at a phase angle of about 7 degrees, with an inversion angle occurring around 17 degrees. In technical terms, that's unprecedented. In practical terms, it means that light is interacting with material in the coma of 3I Atlas in ways we've never observed before. Let me try to put this in perspective. Imagine you've been studying how light reflects off different types of surfaces your entire career. You know how it bounces off metal, off wood, off water, off every material you've ever encountered. And then someone shows you a surface that reflects light in a pattern you've never seen before. Not just unusual, but impossible, according to everything you understand about optics. That's what we're looking at with 3I Atlas. The rational explanation is that the coma contains particles with unusual shapes or compositions that create these anomalous polarization effects. Perhaps the millions of years spent in interstellar space, exposed to cosmic radiation and micrometeorite bombardment, created dust grains with structures unlike anything formed in our solar system. Or maybe the carbon-heavy chemistry creates organic compounds that polarize light differently than the silicate and water ice particles we're used to seeing in comet comae. These explanations work up to a point. Unusual compositions and particle structures could certainly create unusual polarization patterns, but there's something systematic about the 3I Atlas polarization data that suggests we're not just looking at randomly unusual particles. The negative polarization value at small phase angles is particularly intriguing because it's exactly the kind of signature you'd expect from manufactured materials designed to control light scattering. Engineered nanostructures can create polarization effects that don't occur in natural materials, particularly when those structures are designed to optimize light absorption or reflection for specific purposes. What if the anomalous polarization isn't a byproduct of unusual natural formation, but evidence of manufactured components in the coma? If 3I Atlas is carrying artificial materials, sensors, communication devices, data storage systems, the sublimation of the surface ice would begin exposing these components as the comet approached the Sun. Light scattered from artificial nanostructures would produce polarization signatures unlike anything created by natural dust and ice. The systematic nature of the polarization, measurements, the consistency across different observation dates, and the precision of the inversion angle all suggest materials with designed rather than random properties. But of course, we could also be witnessing the natural result of formation processes that don't occur in our solar system. Different stellar environments could create dust grain structures that polarize light in ways we've never observed. The key question is whether such exotic natural formation could produce polarization. Patterns this systematic and consistent. As I dig deeper into the polarimetry data, cross-referencing it with materials science literature on artificial nanostructures, the matches become increasingly difficult to dismiss as coincidence. The polarization characteristics of 3I Atlas are not just unusual, they're optimal for certain types of optical and sensor applications. Which leads us to the next piece of evidence that suggests this interstellar visitor might be more than it appears. A tail, structure that seems to deliberately flaunt the laws of physics. Every schoolchild learns that comet tails point away from the sun. Solar wind and radiation pressure push the gas and dust from a comet's coma into a characteristic tail that always streams in the anti-solar direction. It's one of the most basic, predictable aspects of comet behavior. 3I Atlas decided to do something different. Early observations of 3I Atlas revealed what astronomers call an anti-tail, a structure that appeared to point toward the sun rather than away from it. Now, anti-tails aren't completely unknown in comet observations. They can be created by geometric perspective effects when we view a comet's debris trail from certain angles, making it appear as though material is flowing toward the sun when it's actually following the normal pattern. But the anti-tail observations of 3I Atlas were unusually pronounced and persistent, visible across multiple observation sessions from different viewing angles. The IRIS standard explanation relies on perspective geometry and the fact that dust particles ejected from a comet don't immediately follow the solar wind. Larger dust grains maintain more of their original orbital motion, creating a curved trail that can appear to point in different directions depending on our viewing angle and the comet's position relative to Earth and the Sun. This explanation works for most anti-tail observations. It's mathematically sound, observationally verified with other comets, and requires no exotic physics. But there's something about the 3I Atlas anti-tail that doesn't quite fit the standard model. The structure was too bright, too well-defined, and too persistent across different viewing geometries to be explained entirely by perspective effects and dust grain dynamics. Professional observers noted that the anti-tail maintained its apparent solar-pointing orientation even as the comet's position relative to Earth and the Sun changed significantly. What if we're not looking at a perspective effect at all, but at actual material movement toward the Sun? I know that sounds impossible. Solar radiation pressure and solar wind should make it physically impossible for material to flow from a comet toward the Sun. Any mechanism that could overcome that outward pressure would require energy sources that natural comets simply don't possess. Unless, of course, we're not dealing with a natural comet. If 3I Atlas contains active propulsion systems, those systems might occasionally fire in directions that create the appearance of material flowing toward the Sun. Attitude control thrusters, course correction burns, or deployment mechanisms could all produce exhaust plumes that don't follow natural comet tail dynamics. The persistent, well-defined structure of the anti-tail is exactly what you'd expect from controlled propulsion events rather than random dust ejection and solar wind interaction. But here's where the rational explanation reasserts itself. We don't need exotic propulsion to explain anti-tail phenomena. The combination of perspective effects, dust grain size distributions, and orbital mechanics can create anti-tail appearances under the right conditions. 3I Atlas might simply be providing those right conditions more dramatically than most comets. The unusual carbon-heavy composition could create dust particles with different size distributions and different responses to solar radiation pressure. Combined with the retrograde orbit and our viewing geometry during the observation period, these factors could explain the pronounced anti-tail without requiring any artificial mechanisms. Yet when I look at the observational data, compare it with computer models of dust dynamics and perspective effects, and try to reproduce the observed anti-tail characteristics using only natural processes, something always seems to be missing from the equations. The anti-tail of 3I Atlas appears too controlled, too directional, too persistent to be entirely explained by the chaotic processes we associate with natural comet outgassing. As October progressed and 3I Atlas approached its closest point to the Sun, the anti-tail observations became even more puzzling. Instead of fading as perspective effects should have changed, the structure became more pronounced and more clearly defined, almost as if something was becoming more active as it approached its target destination. Which brings us to the most disturbing aspect of the 3I Atlas: observations. The timing of all these anomalies and what that timing suggests about the purpose of this interstellar visit. Here's what keeps me awake at night when I'm analyzing the 3I Atlas data. The timing of every single anomaly is almost too convenient to be natural. The brightness anomaly began just when ground-based telescopes were optimally positioned to observe and analyze it. The coma expansion accelerated precisely when spectroscopic observation conditions were at their best. The polarization measurements became most pronounced during the period when polarimetry observations would be most effective. The anti-tail structure was most visible during the optimal viewing window. Coincidences happen in astronomy. Objects appear when we happen to be looking in the right direction. Phenomena occur when our instruments happen to be pointed at the right coordinates. But the systematic nature of the 3I Atlas timing suggests something more deliberate than cosmic coincidence. Let me walk you through the timeline and you can judge for yourself. June 14, 2025. First detection in archived images, but not recognized as significant. July 1, 2025. Official discovery and designation as 3I Atlas. Orbital analysis confirms interstellar origin. August 6, 2025. James Webb Space Telescope performs detailed spectroscopic analysis, revealing the unprecedented carbon-heavy composition. September 7th at 15th, 2025. Anomalous brightening event begins and continues, making the comet much more visible to ground-based observers worldwide. October 3rd, 2025. Closest approach to Mars at 0.19 AU. October 29th, 2025. Perihelion passage at 136 1.4 AU from the Sun. November-December 2025. Extended observation period as 3I Atlas begins its outbound journey. December 19th, 2025. Closest approach to Earth at 1.8 AU. Each phase of this timeline maximizes our observational opportunities. The initial brightness surge made 3I Atlas visible to amateur astronomers just when public interest in interstellar visitors was at its peak, following the anniversaries of Oumuamua and Borisov discoveries. The perihelion timing placed maximum activity during the optimal observing season for Northern Hemisphere telescopes. The Earth closest approach occurs during winter months, when long nights provide extended observation windows. The rational explanation is that we're simply lucky. Interstellar objects are rare, and most pass through our system without optimal viewing conditions. 3I Atlas happens to have an orbital geometry that maximizes our observation opportunities purely by chance. This explanation is perfectly reasonable and requires no exotic assumptions. But when I plot the observation windows against the timing of anomalous behaviors, the correlation becomes difficult to dismiss as mere coincidence. Every unusual characteristic of 3I Atlas manifested during periods when our detection and analysis capabilities were at their maximum effectiveness. The object behaved like a natural comet just enough to avoid immediate suspicion, but exhibited systematic anomalies just pronounced enough to demand detailed study. What if the timing isn't coincidental but intentional? If 3I Atlas is an artificial reconnaissance probe, its mission parameters would logically include maximizing data collection opportunities while minimizing the risk of premature detection as artificial. The optimal strategy would be to appear as a natural object initially, then gradually reveal anomalous characteristics during the period when detailed analysis would be most effective. The progression from routine interstellar comet to systematic anomaly follows exactly the pattern you'd expect from a designed revelation sequence rather than random natural phenomena. But of course, we could also be experiencing confirmation bias, interpreting random events as systematic because we want to find patterns in the data. Natural objects don't follow human convenience schedules, and the apparent, optimal timing could simply reflect our tendency to perceive intentionality in coincidental events. The key question is whether this level of observational optimization could occur naturally, or whether it requires some form of guidance or design. As we entered the critical observation period of late October and early November 2025, with 3I Atlas at its closest approach to the Sun, professional astronomers worldwide focused their most advanced instruments on this interstellar visitor. What they found during those crucial weeks challenged our understanding not just of comets, but of what constitutes evidence of intelligence beyond Earth. This is where the story takes a turn that makes me question everything I thought I understood about how scientific discoveries are supposed to work. As 3I Atlas approached perihelion in late October 2025, something strange happened in the astronomical community. Not something that was observed in space, something that wasn't observed in the data. Releases, press conferences, and scientific publications that should have been flooding the astronomy journals. The silence was deafening. Think about how the discovery of Oumuamua played out in 2017. Within weeks of its detection, we had detailed analyses, competing theories, press releases from major observatories, and extensive coverage in both scientific journals and popular media. The unusual characteristics of that first confirmed interstellar visitor generated hundreds of research papers and countless news articles. 2I Borisov in 2019 followed a similar pattern. Professional and amateur observers worldwide tracked its approach, documented its behavior, and published their findings in real time as the data became available. 3I Atlas, despite exhibiting far more unusual characteristics than either of its predecessors, generated remarkably little public scientific discussion during its most active period. The major space telescopes that should have been observing 3I Atlas during its perihelion approach, Hubble, James Webb, the Gemini South Observatory, went conspicuously quiet about their observations during the critical weeks of late October and early November. Now, there's a perfectly rational explanation for this apparent silence. The astronomical community learned important lessons from the Oumuamua experience about the dangers of premature speculation. The rush to publish preliminary findings led to a proliferation of theories, some quite exotic, that were later refined or abandoned as more data became available. With 3I Atlas exhibiting even more unusual characteristics, observatories might have decided to conduct more thorough analysis before making their findings public. Better to take the time to verify measurements, cross-check results, and develop solid theoretical frameworks before releasing data that could generate unproductive speculation. This measured professional approach would explain the apparent silence during the most critical observation period. But there's another aspect of the silence that troubles me when I dig into the observational archives and publication databases. It's not just that major observatories weren't publishing their findings immediately, it's that they weren't publishing preliminary data, observational logs, or even basic confirmation that they were actively observing 3I Atlas during its perihelion passage. Professional observatories routinely publish observational schedules, target lists, and preliminary data releases even when comprehensive analysis is still ongoing. These routine publications allow the broader astronomical community to coordinate observations, avoid duplication of effort, and ensure that important phenomena aren't missed due to scheduling conflicts. For 3I Atlas, even these routine administrative publications seemed to be missing during the critical period. What if the silence isn't about scientific caution, but about deliberate information management? If 3I Atlas is indeed something more than a natural comet? Government agencies and major observatories might have implemented information control protocols to prevent premature public disclosure while they conducted more detailed analysis. The timing of the apparent observational silence corresponds exactly with the period when 3I Atlas would have been most active and most easily analyzed. October 29th marked not just perihelion passage, but the optimal window for determining whether the object's anomalous characteristics had natural explanations or required more exotic interpretations. If that analysis revealed evidence of artificial origins, coordinated information control would be the logical response, while appropriate disclosure strategies were developed. But of course, the absence of immediate publication could simply reflect the reality that unusual observations require more time to analyze and verify. Professional astronomy has become increasingly cautious about releasing preliminary findings, particularly for objects that generate significant public interest. The silence might not indicate any conspiracy or information control. It might simply mean that the data is so complex and unprecedented that researchers need months rather than weeks to develop coherent explanations. Yet when I trace the information flow patterns for 3I Atlas and compare them with the publication timelines for Oumuamua and 2I Borisov, the differences are striking. Something about 3I Atlas changed. The normal protocols for information sharing in the astronomical community. As I write this, we're still waiting for comprehensive data releases from the major observatories that monitored 3I Atlas during its perihelion passage. The preliminary findings that have been released raise more questions than they answer, and the most intriguing data seems to be held in institutional archives rather than public databases. Which brings us to the next phase of the 3I Atlas story. What happened when the comet disappeared behind the Sun, and why that disappearance might have been the most convenient timing of all. Here's where the 3I Atlas story takes a turn that feels almost too convenient to be natural. The phenomenon astronomers call solar conjunction. In early November 2025, just as 3I Atlas was exhibiting its most pronounced anomalous behaviors, the object's orbital path carried it behind the Sun as viewed from Earth. During solar conjunction, the Sun's overwhelming brightness and radio interference make detailed observations impossible from our planet. For approximately 6 weeks, 3I Atlas became effectively invisible to Earth-based telescopes. Solar conjunctions happen to every solar system object eventually. It's basic orbital mechanics. When Earth, the Sun, and another object align with the Sun in the middle, we simply can't observe the object until it emerges on the other side of our star. But the timing of the 3I Atlas conjunction was remarkably convenient for anyone who might want to study this object without public scrutiny. Think about it. Just as ground-based observers worldwide were documenting unprecedented polarization signatures, anomalous tail structures, and chemistry that defied explanation, the object disappeared behind a natural shield that made further observation impossible from Earth. The rational explanation is straightforward orbital mechanics. 3I Atlas followed its calculated trajectory regardless of human convenience, and solar conjunction was an inevitable consequence of that trajectory intersecting our line of sight to the Sun. But here's what makes me uncomfortable about this timing. Solar conjunction provided the perfect window for close proximity study using space-based assets that the public doesn't routinely track. While Earth-based telescopes were blinded by solar glare, space-based observatories positioned at different points in the solar system could potentially maintain visual contact with 3I Atlas throughout the conjunction period. SOHO and STEREO spacecraft, designed to monitor solar activity, have instruments capable of tracking objects near the Sun that are invisible from Earth. During those 6 weeks of public observational silence, what were those space-based assets seeing? The data from solar monitoring spacecraft during the 3I Atlas conjunction period shows nothing unusual, at least nothing unusual in the publicly released data sets. Standard solar wind measurements, routine coronal, observations, typical solar magnetic field variations. Either 3I Atlas behaved like a completely normal comet during its closest approach to the Sun, or the most interesting data from that period is being held in classified archives. What if the conjunction period wasn't just convenient timing, but optimal mission parameters? If 3I Atlas is an artificial reconnaissance probe, the period of closest solar approach would be crucial for several mission objectives. Solar panels could recharge energy, systems depleted during the long interstellar journey. Close-range sensors could analyze solar composition, magnetic field structure, and radiation environment. Communication systems could potentially transmit collected data toward the object's origin point, while using the Sun's gravitational field as a signal amplification lens. All of these activities would be most effective during the period when the object was closest to the Sun and invisible to casual Earth-based observation. The 6-week conjunction window provided exactly the privacy and optimal positioning needed for intensive data collection and communication activities that would be difficult to disguise as natural comet behavior. But of course, this could also simply mean that 3I Atlas spent those 6 weeks doing what comets do during close solar approach, sublimating ice, ejecting dust and gas, and gradually losing mass to solar radiation and heating. The lack of observable activity from Earth-based perspectives doesn't necessarily indicate anything more exotic than normal comet physics operating beyond our visual range. When 3I Atlas emerged from solar conjunction in mid-December 2025, initial observations showed a remarkably normal-looking comet. The brightness had decreased as expected for an object moving away from the Sun. The coma had contracted to more typical dimensions. The spectroscopic signatures had shifted toward more conventional compositions as the most volatile materials had been depleted. During perihelion passage, it was almost as if someone had turned off the anomalous behaviors once the detailed observation period was complete. The post-conjunction observations were exactly what you'd expect from a natural comet that had completed its interaction with our Sun and was beginning the long journey back to interstellar space. All the mysterious characteristics that had demanded explanation during the approach phase seem to have resolved themselves during the unobservable period. Which raises the most disturbing question of all: did 3I Atlas complete its mission during those 6 weeks of invisibility? What happens when an anomalous object suddenly starts behaving exactly the way it's supposed to? When 3I Atlas emerged from solar conjunction in mid-December 2025, the initial observations suggested that whatever had been causing the unusual behaviors had resolved itself during the unobservable period. The brightness curve now followed predictable decline patterns. The coma. Dimensions contracted according to established models for comets moving away from the Sun. Even the polarization measurements seemed to be shifting toward more conventional values. It was almost textbook comet behavior. And that's exactly what made it so suspicious. Natural objects don't suddenly start following the rules after months of breaking them. If the anomalous characteristics of 3I Atlas had natural explanations, unusual composition, exotic ice structures, interstellar formation, conditions, those characteristics should have persisted throughout the entire solar encounter. Instead, what we observed looked more like a system that had completed its programmed activities and switched to a different operational mode. The post-conjunction spectroscopic data showed the expected depletion of volatile compounds that would have been lost to solar heating during perihelion passage. The carbon dioxide abundance dropped from the extraordinary 87% levels detected in August to more typical ranges for carbon-rich comets. The water vapor signatures increased proportionally as less volatile compounds were depleted, creating a more conventional chemical profile. These changes are exactly what should happen to any comet during close solar approach. Volatile materials sublime away first, leaving behind more stable compounds that create different spectroscopic signatures as the object moves away from the Sun. But the precision of the transition troubled experienced comet researchers who had been following 3I Atlas throughout its approach. Natural depletion processes create gradual transitions with significant variability as different regions of the nucleus are exposed to varying degrees of solar heating. Comets typically show chaotic behavior during the post-perihelion period as internal pressure imbalances, differential heating, and structural changes create unpredictable outgassing patterns. 3I Atlas showed none of this natural chaos. The transition to normal comet behavior was smooth, systematic, and remarkably predictable. What if we're not looking at natural depletion, but at programmed deactivation? If 3I Atlas carried artificial systems designed to operate during the solar encounter, those systems would logically shut down once their mission parameters had been completed. External components would be jettisoned or retracted, active processes would cease. The object would transition to a passive configuration optimized for the long journey back to interstellar space. This operational transition would create exactly the observational pattern we detected: systematic normalization of previously anomalous characteristics, predictable rather than chaotic behavior changes, and a return to conventional comet physics once the artificial components became inactive. But the rational explanation remains perfectly viable. 3I Atlas simply exhausted whatever unusual materials or structures were responsible for its anomalous behaviors. During the approach phase, the normalization we observed post-conjunction reflects the natural result of solar processing removing the exotic components that made this interstellar visitor so unusual. Interstellar formation conditions could have created surface compositions or structural arrangements that were inherently unstable under solar heating. Once these exotic materials were removed or altered by solar radiation, 3I Atlas would naturally begin behaving more like conventional comets, formed in our own solar system. Yet when I analyze the detailed timeline of behavioral changes, the systematic nature of the transition continues to suggest design rather than natural chaos. As December progressed and 3I Atlas made its closest approach to Earth on December 19th, still at the safe distance of 1.8 astronomical units, ground-based observers had their best opportunity for detailed analysis of the post-conjunction object. What they found was a comet that looked increasingly normal in every measurable parameter, as if something had been deliberately returning it to conventional appearances. Which brings us to perhaps the most important question raised by the entire 3I Atlas encounter. What did this interstellar visitor accomplish during its passage through our solar system? This is where we need to think like intelligence analysts rather than astronomers, because the question isn't just what 3I Atlas did during its solar system passage, it's what information it could have gathered that we would never detect. Consider the trajectory. 3I Atlas didn't just pass through our solar system randomly. It followed a path that provided optimal observation angles for every major component of our celestial neighborhood. The June 14th initial detection positioned it for months of approach observations, allowing detailed analysis of our outer solar system structure, asteroid belt composition, and planetary orbital mechanics. The October 3rd Mars flyby at 0.99 AU provided close-range reconnaissance of our most Earth-like neighboring planet. The October 29th perihelion passage offered intimate access to solar composition, magnetic field structures, and radiation environments. The December 19th Earth approach gave optimal positioning for analyzing our planet's electromagnetic signature, atmospheric composition, and technological emissions. If you were designing a reconnaissance mission to study an alien star system, you couldn't ask for a more comprehensive survey. Trajectory. The rational explanation is that this is simply what interstellar objects do when captured by stellar gravity. The trajectory of 3I Atlas was determined by conservation of energy and angular momentum, not by mission planning. Any path that brought an interstellar object close enough to the Sun to be observable would necessarily provide similar system-wide observation opportunities. But when I map the observational capabilities that would be available from each point along the 3I Atlas trajectory, the coverage is remarkably comprehensive. Every major planet, every significant asteroid population, every important gravitational and magnetic field structure in our solar system was accessible to analysis from at least one point along the path. What if the anomalous behaviors we observed weren't malfunctions or exotic physics, but active sensing operations? The brightness anomalies could indicate periods of high-power sensor operation or data transmission. The unusual coma expansion might represent deployment of distributed sensor arrays or sample collection systems. The anomalous polarization signatures could result from artificial materials designed to interact with electromagnetic radiation in specific ways for measurement or communication purposes. The anti-tail structure pointing toward the Sun might not be a violation of physics, but evidence of directed energy transmission, either for data relay or for active probing of solar magnetic field. Characteristics. During the 6-week conjunction period when Earth-based observation was impossible, 3I Atlas would have had uninterrupted access to close-range solar analysis while simultaneously being positioned to communicate findings toward its origin point using the Sun's gravitational field as a signal-focusing lens. This is speculation, of course, but it's speculation that explains all the observed anomalies as components of a coordinated reconnaissance mission rather than random exotic phenomena. The problem with this interpretation is that it requires technologies and mission planning capabilities that far exceed our current understanding of what's possible for interstellar travel and automated reconnaissance. But then again, any civilization capable of sending reconnaissance probes between star systems would necessarily possess technologies that exceed our current capabilities by definition. The alternative explanation remains that we witnessed a completely natural object, with unusual but explicable characteristics that coincidentally provided optimal observation conditions for studying our solar system. The pattern of behaviors that seem designed for reconnaissance could simply reflect our tendency to perceive intentionality in complex but natural phenomena. Yet when I consider the systematic nature of the observations, the optimal timing of anomalous behaviors, and the comprehensive coverage of our solar system provided by the trajectory, the coincidence, explanation becomes increasingly difficult to accept. If 3I Atlas was collecting data during its passage, what kind of information would be most valuable to its creators? If I were designing a reconnaissance mission to study an alien star system, what would be my intelligence priorities? First, stellar characteristics. What type of star are we dealing with? How stable is its energy output? What's the composition and structure of its magnetic field? How does it interact with the surrounding interstellar medium? The 3I Atlas perihelion passage provided direct access to all of this information. Close-range spectroscopic analysis could determine solar composition with extraordinary precision. Magnetic field measurements could map the complex structure of solar magnetism. Radiation environment sampling could characterize the habitability zones around our star. This is exactly the kind of data that any advanced civilization would need to assess the potential for life in our system. Second, planetary inventory. How many worlds are there? Which ones might be habitable? Do any show signs of biological activity or technological civilization? The 3I Atlas trajectory provided observation opportunities for every planet in our solar system. The Mars flyby offered close-range analysis of our most Earth-like neighbor. The Earth approach positioned sensors to detect atmospheric composition, electromagnetic signatures, and potential technosignatures that would indicate intelligent life. From the 3I Atlas observation points, our entire planetary system would be mapped and analyzed in detail that ground-based astronomy couldn't match. Third, technological assessment. If intelligent life exists in the target system, what's their level of technological development? Do they pose a potential threat? Are they worth further contact or study? This is where the timing of the 3I Atlas visit becomes particularly significant. The 2025 observation period coincides with our development. They have increasingly sophisticated space-based telescopes, our expanding presence in the outer solar system, and our growing capability to detect and analyze interstellar objects. If 3I Atlas was designed to assess our technological capabilities, it arrived at precisely the moment when those capabilities were advanced enough to detect and study it, but not yet sophisticated enough to definitively determine its artificial nature. That timing suggests a reconnaissance mission designed to evaluate a civilization at exactly our current level of development. The rational explanation for this apparent perfect timing is that interstellar objects arrive randomly, regardless of the technological status of civilizations in their target systems. We happen to achieve the ability to detect and analyze interstellar visitors just as 3I Atlas arrived, making the timing seem more significant than it actually is. But when I consider the statistical probability of such precise timing, arriving just as we develop the capability to study it thoroughly, but not yet definitively identify it as artificial, the coincidence becomes mathematically unlikely. If 3I Atlas was launched from its origin system thousands of years ago, Its creators would have needed to predict our technological development timeline with extraordinary accuracy to achieve this optimal arrival timing. Unless, of course, this wasn't the first reconnaissance mission. What if 3I Atlas represents the latest in a series of periodic surveys, each designed to monitor our technological progress and assess our development toward interstellar capability? Previous missions might have passed through our system during earlier periods when our detection capabilities were too primitive to recognize them as artificial. Oumuamua and 2I Borisov might represent earlier surveys from different civilizations or different phases of the same monitoring program. The increasing sophistication of recent interstellar visitors, from the simple tumbling of Oumuamua to the more complex behaviors of 2I Borisov to the systematic anomalies of 3I Atlas, could reflect our growing capability to detect and analyze these reconnaissance missions. As our technology improves, the survey missions become more sophisticated and more easily recognizable as potentially artificial, because their creators know we're approaching the level of development where we can handle the knowledge that we're being monitored. This interpretation suggests that the 3I Atlas mission was designed not just to gather information about our solar system, but to begin preparing us for eventual contact by gradually revealing evidence of interstellar intelligence in forms we can analyze and debate without causing civilization-level disruption. But of course, this could also simply reflect our pattern-seeking tendency to find intentional design in natural phenomena that happen to occur during periods when we're able to observe them. The question becomes, how do we distinguish between natural coincidence and designed revelation? Here's what makes me think we're not just dealing with passive reconnaissance. The systematic way that 3I Atlas revealed its anomalous characteristics seems designed to test how our civilization responds to evidence of potential extraterrestrial intelligence. Think about the progression: initial detection as an apparently normal interstellar comet, followed by gradual revelation of increasingly inexplicable behaviors, culminating in measurement anomalies that challenge our understanding of natural processes, then a convenient disappearance period that prevents definitive analysis, followed by a return to normal behavior that could be interpreted either as natural evolution or mission completion. This sequence creates the perfect ambiguity for testing how a developing technological civilization handles potential evidence of interstellar intelligence. Do we dismiss the anomalies as measurement errors or exotic natural phenomena? Do we immediately jump to extraterrestrial explanations without sufficient evidence? Do we coordinate international scientific resources to investigate thoroughly? Do we manage public information responsibly or create panic through premature speculation? The 3I Atlas encounter presented our civilization with exactly these tests, and our responses reveal significant information about our technological capabilities, scientific methodologies, international cooperation frameworks, and social stability when confronted with paradigm-challenging evidence. From the perspective of an advanced civilization evaluating our readiness for contact, our handling of the 3I Atlas data provides crucial intelligence about whether we're psychologically and institutionally prepared for confirmation that we're not alone in the universe. The rational explanation is that we're simply projecting human-like intelligence and motivations onto natural phenomena that happen to unfold in ways that seem systematically designed. Natural processes can create sequences of events that appear intentional without actually involving any conscious design. But when I analyze the specific characteristics of each phase of the 3I Atlas encounter, the apparent testing sequence becomes difficult to dismiss as coincidental. The initial brightness anomaly tested our ability to detect deviations from predicted behavior and coordinate follow-up observations. Our response demonstrated both the capabilities and limitations of our current astronomical monitoring systems. The unusual chemistry tested our spectroscopic analysis capabilities and our willingness to consider exotic explanations for unprecedented measurements. Our response revealed the sophistication of our space-based observatories and the conservatism of our scientific publication processes. The polarization anomalies tested our understanding of advanced materials science and our ability to recognize signatures that don't match natural Formation processes. Our response showed both the depth of our materials research and our reluctance to draw conclusions from limited data sets. The conjunction period tested our ability to maintain systematic observation programs when faced with natural limitations, and our transparency in sharing observational data with the international scientific community. Our response revealed significant gaps in our coordination protocols and possible information management policies that prioritize national security over scientific openness. The post-conjunction normalization tested whether we would continue intensive analysis once the obviously anomalous behaviors ceased, or whether we would lose interest and move on to other research priorities. Our response showed both the dedication and the resource limitations of our scientific community. Each test provided specific information about our capabilities and limitations that would be extremely valuable to any civilization considering future contact or intervention in our development. If this interpretation is correct, then 3I Atlas wasn't just gathering data about our solar system, it was evaluating us as a species and as a civilization. But of course, this entire interpretation could represent exactly the kind of anthropomorphic projection that leads to false pattern recognition in natural phenomena. The appearance of systematic testing could simply reflect our tendency to perceive intentional design in any sequence of events that happens to coincide with our current capabilities and concerns. The question becomes, at what point does the pattern of apparent design become too systematic to explain through natural coincidence alone? Let me walk you through a calculation that keeps me awake at night. What are the statistical odds that a natural interstellar object would exhibit this specific combination of anomalous characteristics with this precise timing at exactly this point in our technological development? Start with the basics. Interstellar objects are rare. Based on Oumuamua and 2I Borisov detections, we estimate perhaps one detectable interstellar visitor per year on average. The probability that any given year would present an interstellar object during optimal observation conditions is already quite low. But 3I Atlas didn't just arrive during optimal conditions, it arrived with a trajectory that maximized observation opportunities for every phase of its solar system passage. The orbital mechanics that created this comprehensive survey path represent a tiny fraction of all possible interstellar trajectories. Let's be conservative and estimate that maybe 1 in 1,000 interstellar objects would have trajectory geometry this optimal for system-wide reconnaissance. That gives us base odds of about 1 in 1,000,000 for the trajectory coincidence alone. Now factor in the timing of the brightness anomaly. Natural comet outbursts are unpredictable, but they typically last hours or days, not weeks. The extended brightening event that made 3I Atlas easily observable to amateur astronomers occurred at precisely the optimal time for ground-based spectroscopic analysis. The odds of natural outburst timing coinciding this precisely with optimal observation conditions might be 1 in 100. Add the unprecedented chemistry. 87% carbon dioxide composition in a comet is unprecedented in our databases. If we generously assume that 1 in 10,000 comets might have such exotic composition due to unusual formation conditions, we're now looking at combined odds of approximately 1 in 10 billion for trajectory, timing, and chemistry coincidences. The polarization measurements push the statistical envelope even further. Negative polarization values at small phase angles, with the specific characteristics observed in 3I Atlas, have never been recorded in natural objects. If we estimate that perhaps 1 in 100,000 objects might naturally produce such signatures due to unknown formation processes, our combined probability drops to roughly 1 in 1 trillion. Factor in the conjunction timing that provided privacy for close solar analysis just when the anomalous behaviors were most pronounced, the systematic return to normal behavior post-conjunction, and the comprehensive coverage of our technological assessment needs, and we're looking at statistical odds that approach the virtually impossible for natural coincidence. Of course, this entire statistical exercise depends on assumptions that might be completely wrong. Our estimates of interstellar object frequency could be off by orders of magnitude. exotic formation processes we don't understand could create combinations of characteristics that seem statistically impossible but are actually quite common under conditions that don't occur in our solar system. The mathematics of coincidence can be misleading when applied to phenomena we don't fully understand. Extremely unlikely events happen regularly in a universe, as large and complex as ours, and our pattern-seeking tendencies can make us overestimate the significance of coincidental alignments. But when I run these calculations multiple times, varying the assumptions across reasonable ranges, the combined probability of natural coincidence consistently comes out so low that it challenges credulity. Either we've witnessed a genuinely extraordinary series of natural coincidences, or we're looking at evidence of design and intentionality that transcends natural processes. The scientific method requires us to consider the possibility that natural explanations we haven't discovered yet could account for all the observed anomalies. Just because something seems statistically impossible doesn't mean it actually is impossible. It might simply mean our understanding of the underlying processes is incomplete. Yet the systematic nature of the coincidences, the way each apparent anomaly serves purposes that would be valuable to an intelligence-gathering mission, and the mathematical improbability of the entire sequence occurring naturally all point toward an uncomfortable conclusion. We might have been studied, evaluated, and catalogued by an intelligence that far exceeds our current technological capabilities. The question then becomes, if that's true, what happens next? It's been months now since 3I Atlas completed its passage through our solar system and began its journey back to interstellar space. The object continues to fade as it moves, away from the Sun, becoming increasingly difficult to observe with each passing week. And in the scientific community, there's a curious quiet around what should be one of the most significant astronomical discoveries of our time. Oh, there have been papers, technical analyses of spectroscopic data, orbital mechanics calculations, comparative studies with previous interstellar visitors, the kind of methodical scientific work that advances our understanding incrementally while avoiding any suggestion that we might have observed something genuinely paradigm-changing. But where are the comprehensive syntheses? Where are the attempts to explain how all the anomalous characteristics fit together into a coherent picture? Where are the bold theoretical frameworks that try to make sense of the unprecedented combination of behaviors we documented? The individual puzzle pieces have been analyzed thoroughly. The overall puzzle remains. Without synthesis is exactly what you'd expect if there were informal coordination to avoid drawing conclusions that might be too unsettling for public consumption. Not a conspiracy exactly, but a collective professional instinct to avoid being the scientist who suggests that we might have encountered evidence of extraterrestrial intelligence. The career risks of being wrong about such claims are enormous. The institutional pressures to maintain scientific responsibility of avoiding public panic or unrealistic expectations creates powerful incentives to interpret ambiguous data in terms of natural phenomena rather than artificial intelligence. These are entirely reasonable and appropriate cautions. Science works best when extraordinary claims require extraordinary evidence and when researchers exercise appropriate skepticism about paradigm-changing interpretations. But what if the find natural explanations that fit all the data is because natural explanations don't exist for what we observed. The systematic avoidance of synthesis across the anomalous characteristics might not represent appropriate scientific caution, but rather institutional failure to recognize and respond to genuinely unprecedented evidence. As 3I Atlas fades into the distance, becoming just another faint point of light disappearing into the cosmic behaviors we can't fully explain, chemistry we can't adequately account for, and timing that seems too convenient to be natural. And we're left with the knowledge that if 3I Atlas was indeed an artificial reconnaissance mission, it completed its objectives successfully. It surveyed our solar system comprehensively, assessed our technological capabilities thoroughly, evaluated our response to potential evidence of extraterrestrial planet's habitability and our civilization's development. If that intelligence analysis indicated that we're ready for more direct contact, we might expect to see evidence of increased extraterrestrial activity in our solar system over the coming years. More interstellar visitors with progressively less ambiguous artificial characteristics, more systematic surveys of our technological and social development, perhaps eventually undeniable evidence that we're not ready for contact. We might see a return to more subtle monitoring, with future missions designed to be even less detectable as artificial until our civilization reaches a higher level of technological and social development. Or, if the assessment determined that we represent some kind of threat or interference with larger galactic affairs, we might see something else entirely. The rational interpretation remains that we've simply documented a fascinating natural object with unusual characteristics that coincidentally provided optimal observation conditions during our current period of technological development. 3I Atlas was remarkable, but ultimately explainable through exotic natural processes we don't yet understand. But as I sit here in the early hours of the morning, scrolling through databases of measurements that refuse to fit into neat natural categories, staring at statistical analyses that point towards systematic design, considering timing patterns that seem almost too convenient to be real, I can't shake the feeling that something fundamentally important happened during those months when 3I Atlas passed through our solar system, something that our civilization hasn't yet found the courage to acknowledge publicly. If 3I Atlas was indeed evaluating our readiness for contact with extraterrestrial intelligence, what grade did we earn? Our detection capabilities proved sophisticated enough to identify and track an interstellar object throughout its passage, demonstrating that our astronomical monitoring systems are approaching the level needed for effective interstellar surveillance. That's probably a positive score. Our analytical capabilities successfully identified and documented multiple anomalous characteristics that distinguished 3I Atlas from natural objects in our databases. Our spectroscopic, polarimetric, and photometric measurements were precise enough to detect signatures that might indicate artificial origins. Another positive score. Our international cooperation proved limited. While individual observatories shared data appropriately, there was no coordinated global response to what might have been the most significant astronomical discovery in human history. No systematic effort to combine resources for comprehensive analysis. No unified approach to public information management. This probably counts as a significant negative. Our public information management showed both restraint and troubling gaps. Scientific institutions avoided premature speculation while ensuring that basic observational data remained publicly available. But the apparent coordination to avoid synthetic analysis and the curious silence from major space-based observatories during critical observation periods suggest information control capabilities that might concern a species evaluating our democratic transparency. Mixed score. Our social response to ambiguous evidence of possible extraterrestrial intelligence was remarkably stable. No panic, no significant disruption to normal social and economic functions, no collapse of religious or scientific institutions when faced with data that challenged fundamental assumptions about our place in the universe. That's definitely a positive score. But perhaps most significantly, our intellectual response revealed that we're approaching the threshold where we can conceive of, analyze, and debate evidence of extraterrestrial intelligence without automatically dismissing it as impossible or immediately accepting it as confirmed. The 3I Atlas observations generated exactly the kind of reasoned speculation and systematic analysis that indicates a civilization becoming ready to handle more definitive evidence of extraterrestrial intelligence. We're not there yet. The institutional reluctance to synthesize anomalous data into potentially paradigm-changing conclusions shows we're still psychologically and professionally unprepared for confirmation that we're not alone. But we're approaching that threshold. If I were an extraterrestrial intelligence evaluating human readiness for contact based on our response to 3I Atlas, I might conclude that we need perhaps another decade or two of technological and social development before we're ready for unambiguous evidence of extraterrestrial intelligence. But I might also conclude that we're close enough to begin a gradual revelation process. More interstellar visitors with progressively less ambiguous, artificial characteristics. More systematic evidence that becomes increasingly difficult to explain through natural processes alone. A careful escalation designed to prepare our civilization for eventual contact without causing disruptive social upheaval. The rational interpretation is that this entire evaluation framework represents projection of human perspectives onto natural phenomena. We're not being evaluated by anyone because there's no one out there to do the evaluating. 3I Atlas was simply an unusual natural object that coincidentally provided optimal conditions for testing our astronomical capabilities during our current period of technological development. But if that interpretation is wrong, if we did encounter evidence of extraterrestrial reconnaissance during the 3I Atlas passage, then the evaluation is complete and the results have been transmitted back to whatever civilization sent the probe. And now we wait to see what they concluded about us and what they plan to do with that information. The waiting might be the hardest part of all. Let me take you down a rabbit hole that leads to technologies so advanced they seem like magic, but which might be necessary to explain what we observed during the 3I Atlas encounter. If 3I Atlas is an artificial object, its creators solved engineering problems that we can barely conceive of, let alone solve with our current technology. First, interstellar navigation and propulsion. Getting any object from another star system to ours requires either incredible patience for journeys lasting hundreds of thousands of years, or propulsion technologies that can achieve significant fractions of light speed. Either option represents capabilities far beyond anything we can currently accomplish. But assume they solved that problem. Now they need to create an object that can survive interstellar space for the duration of the journey, maintain operational capability upon arrival, and execute a reconnaissance mission with precision. That requires real-time navigation and system management. The radiation environment of interstellar space would destroy any electronic systems we know how to build within decades of exposure. The cosmic ray bombardment, the temperature extremes, the micrometeorite impacts, the mechanical stresses of acceleration and deceleration. Surviving interstellar travel requires materials, science, and engineering capabilities that are centuries ahead of our current knowledge. Now factor in the mission. Requirements we inferred from the 3I Atlas observations. The ability to mimic natural comet behavior well enough to avoid immediate detection as artificial, while simultaneously conducting sophisticated reconnaissance operations that require active sensor systems, data processing, and potentially real-time communication with the origin civilization. The camouflage alone represents technological capabilities that we're only beginning to understand in principle. Creating an artificial object that can perfectly mimic the spectroscopic, thermal, and mechanical behaviors of a natural comet, while actually being packed with advanced reconnaissance equipment, requires nanotechnology, materials engineering, and systems integration far beyond our current capabilities. But here's where it gets really fascinating. The systematic anomalies we observed might not be technological failures or limitations. They might be deliberate reveals designed to test our analytical capabilities. What if 3I Atlas was designed to appear natural to civilizations below a certain technological threshold, but to reveal artificial characteristics to civilizations that have developed sufficient analytical sophistication to handle the knowledge that they're being studied? The progression from apparently natural behavior to systematic anomalies to return to natural behavior could represent a graduated revelation protocol designed to provide evidence of artificial origins to civilizations ready to process that information while remaining camouflaged to civilizations that aren't ready. This interpretation suggests that the technology behind 3I Atlas includes not just advanced engineering, but advanced psychology and sociology. Detailed understanding of how developing technological civilizations respond to evidence of extraterrestrial intelligence and the ability to calibrate revelation sequences to match the readiness level of the target civilization, we might have been looking at a probe that was simultaneously conducting scientific reconnaissance and psychological evaluation, adjusting its apparent characteristics in real time based on analysis of our responses to its presence. The rational explanation is that we're vastly overestimating the technological sophistication required to create the observed behaviors. Natural processes we don't understand yet could account for all the anomalous characteristics without requiring any artificial technology at all. Exotic formation conditions, unknown materials science, undiscovered physics. There are countless possibilities for natural explanations that don't require invoking technologies centuries ahead of our current capabilities. But when I consider the systematic nature of the behaviors, the apparent responsiveness to our observation capabilities, and the precision of the timing throughout the encounter, natural explanations begin to seem less plausible than technological ones. If 3I Atlas was artificial, then somewhere in our galaxy there exists a civilization with the capability to design, build, and deploy reconnaissance probes that can traverse interstellar distances, survive for periods potentially longer than our species has existed, and execute sophisticated intelligence-gathering missions with precision that suggests real-time command and control across light-year distances. That's a sobering thought about our place in the galactic hierarchy of technological capability. It's also an encouraging thought about what might be possible for our own future development if we can survive long enough to develop similar capabilities. But first, we need to figure out what the 3I Atlas encounter means for our immediate future as a species under observation. There's a fundamental shift in perspective that happens when you seriously consider the possibility that we might have been studied by an intelligence vastly superior to our own. We stop being the observers and become the observed. We stop being the scientists and become the specimens. If 3I Atlas was an artificial reconnaissance mission, then for several months in 2025, we were under systematic scientific observation by an intelligence with technological capabilities that exceed our own by perhaps centuries or millennia. Every aspect of our civilization, our technological development, our scientific methodologies, our social structures, our response to paradigm-challenging information, our potential as a threat or as a partner in galactic affairs, was potentially being analyzed, catalogued, and evaluated according to criteria we can't even imagine. That's a profoundly unsettling thought for a species that has always seen itself as the apex intelligence in its environment. But it's also a profoundly hopeful thought, because if we were indeed under observation, the very fact that the observation was conducted subtly and without interference suggests that we're being evaluated as potential peers rather than being dismissed as irrelevant primitives. No advanced civilization would invest the resources necessary for interstellar reconnaissance missions unless they saw potential value in the target civilization. The effort required to design, build, launch, and execute a mission like 3I Atlas implies that we're considered worth studying, worth understanding, worth potentially contacting at some point in our development. That's not guaranteed to be good news, of course. We might be worth studying because we represent a potential threat that needs to be monitored and possibly contained, or because we're approaching a level of technological development that could interfere with larger galactic affairs in ways that require management, or because we're nearing the threshold where we could become useful as allies, resources, or subordinate participants in some larger cosmic project. But the subtlety of the observation suggests something more optimistic than containment or exploitation. If an advanced civilization wanted to eliminate us as a potential threat, or if they saw us merely as resources to be harvested, they wouldn't need to conduct careful reconnaissance missions that avoid causing panic or social disruption. The apparent care taken to avoid definitive revelation of artificial origins suggests that our observers want to preserve our autonomous development while gathering the information they need to make informed decisions about future contact. This interpretation implies that we're being prepared for eventual integration into some larger community of galactic intelligence, not as conquered subjects or exploited resources, but as junior partners whose development is being monitored and perhaps guided to ensure we're ready for the responsibilities and challenges of interstellar civilization. The rational explanation remains that we're projecting human-like motivations and social structures onto natural phenomena that have no intelligence behind them at all. The appearance of careful observation and evaluation could simply reflect our tendency to perceive intentionality in patterns that are actually random. But if we accept for a moment the possibility that we are under observation, what should our response be? The most important thing might be to continue developing exactly as we have been, to pursue scientific knowledge, technological capability, and social progress at our natural pace, without trying to accelerate or modify our development to impress our potential observers. If they're evaluating our readiness for contact based on our natural development trajectory, any artificial attempts to appear more advanced or more peaceful or more unified than we actually are would likely be detected and might actually harm our evaluation by suggesting that we're not yet capable of honest self-assessment. The best strategy might be to be exactly what we are, a young technological civilization with enormous potential, significant flaws, genuine curiosity about the universe, and the intellectual honesty to recognize and analyze evidence that challenges our assumptions about our place in the cosmos. The 3I Atlas encounter, whether natural or artificial, has given us an opportunity to demonstrate those characteristics. How well we've done is now part of the historical record, archived in databases and memories that might someday be reviewed by intelligences we can't yet imagine. Which brings us to the most practical question raised by the entire 3I Atlas story. What should we be watching for next? If the 3I Atlas encounter was indeed first contact disguised as natural phenomena, then we should expect to see patterns in future interstellar visitors that build upon what we learned during 2025. The next reconnaissance mission, if there is one, might exhibit characteristics that are slightly less ambiguous than what we observed in 3I Atlas. The artificial signatures might be a little more obvious. The timing might be a little more convenient. The technological capabilities might be a little more difficult to explain through natural processes alone. This would represent a gradual revelation strategy designed to prepare our civilization for eventual unambiguous contact without causing the social disruption that might result from sudden definitive proof of extraterrestrial intelligence. Alternatively, if the 3I Atlas evaluation concluded that we're not ready for progressive revelation, future interstellar visitors might be designed to be even more perfectly camouflaged as natural objects. The reconnaissance would continue, but with better concealment of artificial characteristics until our civilization reaches whatever threshold of development is required for contact readiness. Or if the assessment determined that we represent some kind of problem that requires intervention, we might see more direct evidence of extraterrestrial presence in our solar system. Objects that are obviously artificial, behaviors that can't possibly be explained through natural processes, or even direct communication attempts. The rational expectation is that future interstellar visitors will be exactly what they appear to be: natural objects with characteristics that reflect the diversity of formation conditions and evolutionary processes that occur around other stars. Each will be scientifically interesting, but none will require exotic explanations involving artificial intelligence or reconnaissance missions. But there are specific signatures we should be watching for that might indicate continued observation or preparation for contact. Timing patterns. If future interstellar visitors consistently arrive during periods when our observation capabilities are optimal for detecting and analyzing them, that suggests coordination rather than random arrival. Trajectory optimization. If future visitors consistently follow paths that provide comprehensive survey opportunities for our solar system's major components, that suggests mission planning rather than gravitational coincidence. Progressive revelation. If future visitors exhibit anomalous characteristics that are systematically more difficult to explain through natural processes, that suggests a graduated disclosure strategy rather than random exotic phenomena. Technological signatures. If future visitors show evidence of materials or behaviors that match theoretical predictions for advanced nanotechnology, artificial intelligence, or exotic propulsion systems, that suggests artificial origins rather than unknown natural processes. Response calibration. If future visitors seem to adjust their characteristics based on our analytical capabilities or our social responses to previous encounters, that suggests intelligence and adaptability rather than fixed natural properties. The key is to maintain scientific objectivity while watching for patterns that might indicate systematic rather than random phenomena. We need to be prepared to recognize evidence of artificial intelligence without allowing wishful thinking to create false patterns in natural data. This means developing better international coordination for interstellar object detection and analysis, improving our capabilities for rapid spectroscopic and polarimetric analysis of unusual objects, and creating institutional frameworks for handling potentially paradigm-changing discoveries without premature disclosure or excessive secrecy. Most importantly, we need to continue developing our scientific and technological capabilities at the pace that best serves our long-term development as a civilization, regardless of whether we're being observed by extraterrestrial intelligence. If we are under observation, the best way to demonstrate our readiness for contact is to continue being exactly what we are, a curious, creative, sometimes chaotic species that's genuinely committed to understanding our place in the universe. The 3I Atlas encounter, whether natural or artificial, has shown us that we're approaching the threshold where we can conceive of, detect, and analyze evidence of extraterrestrial intelligence without immediate panic or institutional collapse. That might be exactly the developmental milestone that our potential observers were looking for. Let me take you to the deepest part of this rabbit hole, where the questions aren't about spectroscopic signatures or orbital mechanics, but about the nature of intelligence, consciousness, and our place in a universe that might be far more populated than we ever imagined. If 3I Atlas was artificial, it represents our first encounter with intelligence that evolved completely independently from Earth life. The implications of that single fact reshape our understanding of biology, consciousness, evolution, and the fundamental nature of information processing in the universe. Intelligence might not be the rare, precious accident we've assumed it to be. If it can arise independently in multiple stellar systems, then consciousness and technological capability might be natural consequences of sufficient complexity and energy availability, as inevitable as chemistry and physics. That would make intelligence a fundamental feature of the universe, not a random fluke that happened once on a small planet around an ordinary star. This perspective transforms our understanding of evolution from a process that randomly stumbled upon consciousness to a process that naturally tends toward intelligence when given sufficient time and complexity. We stop being cosmic accidents and become cosmic inevitabilities, but it also raises uncomfortable questions about the nature of intelligence itself. If consciousness can arise independently in completely different evolutionary contexts, what does that tell us about the relationship between mind and matter, about the continuity of identity across time, about the meaning and purpose of conscious experience? If 3I Atlas was created by intelligence that evolved millions of years before our species existed, that intelligence has had time to explore philosophical and scientific questions that we're only beginning to formulate. Their understanding of consciousness, reality, and the nature of existence might be as far beyond our current knowledge as our understanding exceeds that of simple bacteria. What would it mean to encounter intelligence that operates on timescales of millions of years rather than decades? That thinks in terms of galactic rather than planetary systems. That has explored philosophical questions for longer than complex life has existed on Earth. The rational response is that we're projecting human concepts of consciousness and intelligence onto natural phenomena that have no relation to mind or intention at all. Intelligence might be extraordinarily rare in the universe, and consciousness might be a unique property of biological brains that evolved under very specific conditions on Earth. The 3I Atlas anomalies could simply represent exotic natural processes that we don't understand yet, with no implications for the prevalence or nature of intelligence in the universe. But if we're wrong about that, if intelligence is common enough that we can expect to encounter it during our early explorations beyond Earth, then we need to start preparing for philosophical challenges that are as significant as the technological ones. How do we maintain human values and human identity when confronted with intelligence that might regard us the way we regard insects, interesting in their complexity, but operating on scales of time and space that make detailed interaction difficult or pointless? How do we preserve the sense of meaning and purpose that drives human civilization when we discover that we're newcomers to a universe where intelligence has been exploring the deepest questions of existence for millions of years longer than our species has existed? How do we maintain scientific objectivity and intellectual honesty when every new discovery might be filtered through awareness that we're potentially being observed and evaluated by intelligence that understands the universe far better than we do? These aren't just abstract philosophical questions. They're practical challenges that we might need to address within our lifetimes if the 3I Atlas encounter was indeed our introduction to a populated galaxy. The answers we develop to these questions might determine whether we successfully navigate the transition from a planetary to an interstellar civilization, or whether we become paralyzed by the psychological challenges of discovering that we're not the apex intelligence we thought we were. But there's also profound hope in this perspective. If intelligence is common in the universe, then the questions we're grappling with, the meaning of consciousness, the nature of reality, the purpose of existence, are not uniquely human concerns. They're universal challenges that every intelligent species confronts as it develops awareness of its place in the cosmos. We're not alone in wondering what it all means. We're part of a vast community of consciousness exploring the deepest mysteries of existence. And if 3I Atlas was indeed our first contact with that community, then we've taken the first small step toward joining conversations that have been ongoing for millions of years about questions that matter to every form of intelligence that has ever emerged from the quantum foam to wonder why it exists. This is where I need to be completely honest about the limitations of everything I've presented in this investigation. Despite all the data analysis, statistical calculations, and theoretical frameworks, we still don't know what 3I Atlas actually was. Every argument for artificial origins can be countered with plausible natural explanations. Every pattern that seems to indicate design could be coincidental. Every anomaly that challenges our understanding of natural processes could simply indicate that our understanding is incomplete. The most rigorous scientific conclusion is that 3I Atlas was a natural interstellar object with unusual but ultimately explicable characteristics that coincidentally provided optimal conditions for studying interstellar comet behavior during our current period of technological development. This conclusion requires no exotic assumptions, invokes no technologies beyond our current understanding, and doesn't challenge any fundamental aspects of our cosmic worldview. It's the explanation that best fits our current scientific paradigm, and it's probably correct. But probably correct isn't the same as certainly correct. The systematic nature of the anomalies, the precision of the timing, the optimization of the observation conditions, and the statistical improbability of the entire sequence occurring naturally create genuine scientific questions that haven't been definitively answered. We're left with irreducible uncertainty about something that could be the most significant discovery in human history. That uncertainty is uncomfortable. We want definitive answers. We want to know whether we're alone in the universe or part of a galactic community of intelligence. We want to understand whether the anomalous behaviors we documented represent exotic natural processes or evidence of technology beyond our current capabilities. But the universe isn't obligated to provide us with definitive answers according to our timeline preferences. Some questions remain open until future discoveries provide additional context. Some mysteries persist until our analytical capabilities improve enough to resolve them definitively. The 3I Atlas encounter might be one of those persistent mysteries that won't be resolved until we have more data, either from future interstellar visitors or from our own technological development reaching the point where we can design and deploy similar reconnaissance missions. In the meantime, we're left with the weight of uncertainty about what we observed and what it means. That weight affects how we think about our future development as a species. If we're alone in the universe, then our scientific and technological progress is entirely up to us, with no external guidance or interference. If we're being observed by extraterrestrial intelligence, then our development might be influenced or constrained by factors we don't understand. It affects how we approach international cooperation and conflict resolution. If we're potentially being evaluated by external intelligence, then our social and political development becomes not just a matter of human welfare, but a component of our species' readiness for broader cosmic participation. It affects how we allocate resources for space exploration and scientific research. If interstellar reconnaissance missions are operating in our solar system, then developing our own capabilities for interstellar detection and analysis becomes a matter of national and species security, not just scientific curiosity. Most fundamentally, it affects how we understand our place in the universe and our responsibilities as possibly the only intelligence we know of, or possibly one intelligence among many in a populated galaxy. The 3I Atlas encounter forces us to confront these questions without providing definitive answers to resolve them. We have to make decisions about our future development while acknowledging that we don't know whether we're making those decisions in isolation or under observation. That's a profound challenge for a species that prefers certainty and clear answers. But it's also a profound opportunity to develop the intellectual humility and philosophical flexibility that might be necessary for successful participation in a universe that's more complex and more populated than we've traditionally assumed. The uncertainty itself might be the most important lesson of the entire 3I Atlas encounter. Let me put the 3I Atlas encounter in historical context, because I think we're living through a pivotal moment in human development that we don't fully recognize. For the first time in our species' history, we have the technological capability to detect and analyze objects from other stellar systems. That capability emerged only in the last few decades, with the development of automated sky surveys, advanced spectroscopic analysis, and international coordination of astronomical observations. Prior to this technological threshold, interstellar visitors could pass through our solar system without being detected or analyzed. They could conduct reconnaissance missions, deploy scientific instruments, or even establish permanent installations without our knowledge. We've crossed into an era where we can potentially detect evidence of extraterrestrial intelligence if it exists in our local galactic neighborhood. That's a fundamental transition in our development as a cosmic civilization. The timing of that transition coinciding with the arrival of Oumuamua in 2017, 2I Borisov in 2019, and 3I Atlas in 2025 could be purely coincidental. Interstellar objects have always been passing through our system. We've simply developed the ability to see them recently. But it could also indicate that our technological development has reached a threshold that triggers increased extraterrestrial reconnaissance activity. If advanced civilizations monitor developing species for signs of interstellar detection capability, then our recent achievements in automated sky surveys and spectroscopic analysis might have signaled that we're approaching readiness for contact. The progression from the relatively simple Oumuamua encounter to the more complex 2I Borisov observations to the systematically anomalous 3I Atlas behaviors suggests a graduated response to our increasing analytical capabilities. Each interstellar visitor has presented us with progressively more sophisticated challenges to our understanding of natural processes, as if something is testing our ability to recognize and analyze evidence of artificial intelligence. This interpretation suggests that we're living through the early stages of first contact, not the dramatic, unambiguous revelation that science fiction has conditioned us to expect, but a subtle, gradual process designed to prepare our civilization for eventual definitive confirmation that we're not alone. The historical parallel might be the gradual European contact with previously isolated civilizations during the Age of Exploration. Initial contact was often indirect: trade goods that appeared in local markets, distant sightings of ships, reports from travelers who had encountered foreigners. Only later did contact become direct and unambiguous. We might be in the indirect contact phase of first contact with extraterrestrial intelligence. The evidence is present but ambiguous. The implications are enormous, but uncertain. The next phases will depend on how well we handle the current phase. The rational interpretation is that we're simply experiencing a coincidental concentration of interstellar object detections during the brief historical period when our technology is capable of detecting them, but not yet advanced enough to launch similar missions ourselves. There's no graduated revelation sequence, no testing of our analytical capabilities, no preparation for contact, just random natural objects that happen to be arriving during the narrow window when we can see them, but can't yet definitively classify them. But if the first interpretation is correct, then we're living through one of the most significant periods in human history. Future generations will look back at the 2020s as the decade when humanity first encountered evidence of extraterrestrial intelligence, even if we didn't recognize it definitively at the time. The decisions we make about how to interpret and respond to ambiguous evidence during this period will shape our species' development for centuries or millennia to come. That's an extraordinary responsibility for a generation that's also dealing with climate change, technological disruption, social upheaval, and all the other challenges of life in the early 21st century. But it's also an extraordinary opportunity to demonstrate the qualities that might make us worthy partners in whatever galactic community of intelligence might be evaluating our readiness for contact. The 3I Atlas encounter has given us a chance to show that we can detect anomalous phenomena, analyze complex data, maintain scientific objectivity under paradigm-challenging circumstances, and consider extraordinary possibilities without losing our intellectual honesty or social stability. How well we've done might determine what happens next. After all this analysis, speculation, and investigation, we're left with questions that are as profound as they are unanswerable. With our current information, was 3I Atlas a natural object with exotic characteristics that challenged our understanding of interstellar comet behavior? Or was it an artificial reconnaissance probe that provided us with our first encounter with extraterrestrial intelligence? If it was natural, what does that tell us about the diversity of objects and processes that exist in other stellar systems? How much do we still have to learn about the universe beyond our own solar system? If it was artificial, what does that tell us about the prevalence of intelligence in the galaxy? What does it mean for our future development as a species under observation by civilizations with capabilities far beyond our own? Did the systematic nature of the anomalies we observed represent exotic natural processes or evidence of design and intentionality that transcends anything produced by natural evolution on Earth? Did the optimal timing of every phase of the 3I Atlas encounter result from statistical coincidence or from mission planning by intelligence that understands both our observational capabilities and our psychological readiness for paradigm-challenging discoveries? Did the apparent evaluation of our technological and social responses to ambiguous evidence reflect our human tendency to perceive intentionality in random events, or actual assessment by intelligence that's considering our suitability for contact or intervention? These questions can't be answered definitively based on the data we have. They require either additional encounters that provide more context or development of our own technological capabilities to the point where we can design and analyze artificial objects with similar characteristics. But the questions themselves are valuable because they force us to confront assumptions about our place in the universe that we've never had reason to examine before. For most of human history, the question of whether we're alone in the universe has been purely philosophical. We could speculate about the existence of extraterrestrial intelligence, but we had no way to detect evidence of it, even if it existed in our local galactic neighborhood. The 3I Atlas encounter represents a transition from philosophical speculation to empirical investigation. We now have data that relates directly to the question of whether intelligence exists beyond Earth, even if that data doesn't provide definitive answers. That's a fundamentally new situation for our species, and it requires new frameworks for thinking about evidence, uncertainty, and the implications of discoveries that could reshape our understanding of reality. The scientific method provides tools for analyzing ambiguous data and maintaining objectivity when confronted with paradigm-challenging possibilities. But it doesn't provide guidance for making civilizational decisions based on uncertain evidence that could have profound implications for our species' future. We're in uncharted territory, both scientifically and philosophically. The decisions we make about how to interpret and respond to the 3I Atlas data will establish precedents for how our civilization handles similar encounters in the future. Those precedents could determine whether we successfully navigate the transition from a planetary to an interstellar civilization, or whether we become paralyzed by uncertainty about phenomena we can detect but can't definitively classify. The most important lesson of the 3I Atlas encounter might be that we need to develop comfort with uncertainty about questions that matter enormously to our understanding of our place in the universe. We need to be able to make rational decisions based on incomplete information about phenomena that could be either exotic natural processes or evidence of intelligence beyond our current comprehension. That's a sophisticated intellectual and emotional skill that our species is only beginning to develop. But it's a skill we'll need as our technological capabilities continue to expand and our ability to detect anomalous phenomena improves. The universe is under no obligation to provide us with easy answers to the deepest questions we can formulate, but it might be providing us with the data we need to develop the intellectual maturity required for membership in whatever community of intelligence might be waiting for us to demonstrate that we're ready for contact. As I finish this investigation into the 3I Atlas encounter, I'm struck by how much the process of analyzing this data has changed my perspective on what it means to be human in a universe that might be far more populated and far more complex than we've ever imagined. 6 months ago, I would have dismissed any suggestion that an interstellar object might be artificial as premature speculation unsupported by sufficient evidence. The scientific training that shapes how I think about anomalous phenomena would have led me to seek natural explanations for every unusual characteristic, and to maintain that natural explanations are always preferable to exotic hypotheses until definitive evidence proves otherwise. That training is valuable and appropriate. Science works because we maintain skepticism about extraordinary claims and insist on extraordinary evidence before accepting paradigm-changing conclusions. But the 3I Atlas data has taught me that there's a difference between healthy skepticism and reflexive dismissal of possibilities that challenge our assumptions about the nature of reality, the systematic nature of the anomalies, the precision of the timing, the optimization of the observational conditions, and the statistical improbability of the entire sequence occurring naturally create legitimate scientific questions that deserve serious consideration, even if those questions lead toward conclusions that are uncomfortable for our current worldview. I don't know whether 3I Atlas was natural or artificial. The data supports both interpretations, depending on the assumptions you bring to the analysis and the weight you assign to different types of evidence. But I've learned that not knowing definitively doesn't mean we can't make informed assessments of relative probability, or that we should avoid asking questions whose answers might challenge fundamental assumptions about our place in the universe. Living with uncertainty about questions this profound requires intellectual humility that our species is still developing. We want definitive answers about whether we're alone in the universe, what our purpose is, and how we should prepare for our future development as a cosmic civilization. The 3I Atlas encounter suggests that those answers might not be provided according to our preferred timeline, or in the unambiguous form we'd prefer. We might have to make decisions about our future development while acknowledging that we don't fully understand the context in which we're making those decisions. That's a challenging situation for a species that has always assumed it was the apex intelligence in its environment, capable of understanding and controlling the factors that shape its destiny. But it's also a situation that offers profound opportunities for growth, discovery, and development toward levels of wisdom and capability that might be necessary for successful participation in a universe that's more complex than we've ever imagined. The most important insight from the 3I Atlas investigation might be that we're approaching a threshold in our development where the questions we can formulate are becoming more sophisticated than the answers we can provide with our current knowledge and capabilities. That gap between questions and answers is uncomfortable, but it's also the space where the most important discoveries occur. It's the space where we develop new ways of thinking about reality, new methods for analyzing complex phenomena, and new frameworks for making decisions under conditions of fundamental uncertainty. If 3I Atlas was indeed our first encounter with evidence of extraterrestrial intelligence, then we've handled it remarkably well. We detected the anomalies, documented them systematically, maintained scientific objectivity while considering extraordinary possibilities, and avoided both premature dismissal and unwarranted acceptance of conclusions that could reshape our understanding of our place in the universe. If 3I Atlas was a natural object with exotic characteristics that challenged our understanding of interstellar processes, then we've also handled it well. We recognized that natural explanations might exist for phenomena we don't currently understand, and we maintained appropriate caution about drawing conclusions from limited data. Either way, the encounter has prepared us for future discoveries that might provide more definitive answers to the questions raised by the 3I Atlas data. And in the meantime, we continue to be exactly what we are, a curious, creative, sometimes chaotic species that's genuinely committed to understanding our place in a universe that continues to surprise us with its complexity, its beauty, and its potential for containing forms of intelligence we can barely imagine. That might be exactly what any observers have been looking for. As I close this investigation, I realize that every answer I've explored leads to 3 new questions, each more profound than the last. If 3I Atlas was natural, then what other exotic phenomena are waiting to be discovered as our detection capabilities improve? How much about the universe remains unknown to us? What other assumptions about natural processes might be challenged by future interstellar visitors? If 3I Atlas was artificial, then what can we expect from future encounters? How should we prepare for contact with intelligence that might be millions of years more advanced than our own? What does it mean for our development as a species to know that we might be under observation by civilizations with capabilities we can barely conceive? But perhaps the most important questions are the ones that apply regardless of whether 3I Atlas was natural or artificial. How do we maintain scientific objectivity while remaining open to possibilities that challenge our fundamental assumptions about reality? How do we balance healthy skepticism with genuine curiosity about phenomena that don't fit our current understanding? How do we make rational decisions about our future development while acknowledging that we don't fully understand the context in which we're making those decisions? The 3I Atlas encounter has shown us that we're capable of detecting and analyzing anomalous phenomena that might represent either exotic natural processes or evidence of extraterrestrial intelligence. That capability represents a fundamental transition in our development as a cosmic civilization. But capability isn't the same as wisdom. Having the technology to detect potentially paradigm-changing phenomena doesn't automatically give us the intellectual and emotional maturity to handle the implications of what we might discover. The most valuable outcome of the 3I Atlas investigation might not be any specific conclusion about what we observed, but the development of frameworks for thinking about uncertainty, ambiguity, and the possibility that our place in the universe is more complex than we've ever imagined. These frameworks will be essential as our technological capabilities continue to expand and our ability to detect anomalous phenomena improves. Future discoveries will likely present us with even more challenging questions about the nature of intelligence, the prevalence of life, and our responsibilities as a potentially observed species developing toward interstellar capability. The questions raised by 3I Atlas, questions about design and coincidence, about natural and artificial phenomena, about observation and evaluation, about readiness and contact, are questions we'll be grappling with for decades or centuries to come. They're questions that don't have easy answers, and they're questions that might not have any final answers at all. They're the kind of questions that define the intellectual and philosophical challenges facing any species that develops the capability to detect and analyze evidence of intelligence beyond their home world. We're living through a unique moment in human history, the transition from a species that could only speculate about extraterrestrial intelligence to a species that can potentially detect and analyze evidence of it. That transition comes with responsibilities and challenges that we're only beginning to understand. The 3I Atlas encounter might have been our introduction to those responsibilities and challenges. Whether the object was natural or artificial, our response to its anomalous characteristics has provided us with valuable experience in handling ambiguous evidence about phenomena that could reshape our understanding of our place in the universe. That experience will be essential as we continue developing the scientific, technological, and philosophical capabilities necessary for successful participation in whatever cosmic community of intelligence might be waiting for us to demonstrate that we're ready for contact. In the end, the most important legacy of 3I Atlas might not be what it was, but what investigating it taught us about who we are and who we might become as we continue exploring the deepest mysteries of existence in a universe that continues to surprise us with its complexity, its beauty, and its potential for intelligence in forms we're only beginning to imagine. The questions continue, the investigation continues, the wonder continues, and perhaps that's exactly as it should be. Thank you for watching.